Okay, hello everyone, welcome back. In the previous weeks, we have been talking about the definition of requirements. Moreover, I have been asking you to identify requirements from a video, from our discussions in the classroom, video games, this project from other students. We know what is a requirement. Therefore, now we can move to the specification of the requirement. So far, I have been asking you to identify which one is and which one is not a requirement, period. And I have been asking you to identify verbs, the actions, to try to be clear in what do you want to specify as this is something that the software is going to do. But so far, we haven't talked about a particular format, template, or way to document those requirements. Your homeworks have been, and is going to be the next one, basically use natural language and try to communicate your ideas in the best way possible. And there are going to be ambiguities, synonyms, differences. And so far we are okay because the goal has been use be sure that you know what is considered a service, a reaction, a functionality in the system, and what is not. And hopefully by now we know that. Now, moreover, all these things that we have reviewed, your experience with homework 1 and your experience with homework 2, that by the way is going to open today, are summarized in a paper that I asked you to read a long time ago. It's a paper that is on Canvas. You can take a look. It is not mandatory to read the paper. I am going to summarize here in some slides the content of the paper, the key ideas. Those key ideas could be in one of your quizzes. So if you do not read the paper, at least be sure that the key ideas are clear. Yeah, don't worry. We're going to continue practicing. For the comment in the chat, it is not simple. And the first thing that I want you to notice is it is not trivial. It is not anything is a requirement. So the fact that you notice now like, no, this is not exactly anything is correct. We're moving in the correct direction. Now, we need to review the correct answers and we're going to work on that. Something that is going to help us is, well, we're going to review the correct answers. What about also using a correct template or a correct way to document those correct answers? Because that is something that we need. And hopefully you agree with me that is something that we're missing. Even if you have the correct ideas, some of you have it in the previous lecture, it's like, well, but how we put those ideas in a document or in a slide, in a paper, in a document to submit our next step. So we're going to check correct answers and we're going to check correct ways to document those answers. It's going to make more sense. And don't worry, we're going to go back to the project that I asked you to do as a homework. We're going to go back to the Pac-Man and to the other 2 games that we have been reviewing. We have a bunch of projects that I have been mentioning, that I have been asking you to explore. We need to create the correct answers in a correct representation for all of them. And that is going to be helpful. So moving to that. Now, guys, the fact that you are asking right now, that is like, this is not trivial. This is not like anything is correct, as I mentioned before. That is the key idea that you read in the paper that I shared with you. It's not me telling you this is hard. It's not me telling you not anything is a requirement, be careful. Things are in that way. We need to be very careful about what we call a requirement, because the requirement is going to be the key ideas for quality, in particular, the non-functional requirements. But also, the functional requirements are going to be the key idea for the cost of the software. In particular, for the cost effectiveness of the project. Using the requirements, those things that you identify as a requirements, you're going to calculate how much the cost is going to be for this system. And that includes how many people is going to work on this and how many time those people are going to need. Previous lecture, the system that I asked you to review in my video. Hopefully you notice at the end, after we review several different options and so on, we have 7 requirements, 8 maybe. 8 requirements, and moreover, we all agree that even though we moved to requirements, all those 8, they were small, borderline requirements, very small, very simple, very trivial. It's a small system. When you evaluate the cost, you're not going to tell me that you need 8 people for the project. Even 4 people is a lot. All those small things, all those small requirements are not going to be something that one person is going to work in 2 weeks. One person in 2 weeks can work 2 or 4 of the things that we identify as functionalities for that system. The cost. Moreover, the quality. All those things that the customer asks about performance, robustness, and so on, we need to identify if really those are needed. Anything that you want to put here in quality, higher the quality, higher the cost, period. So performance is important. It's going to cost more testing, more work in the development, better choices, better algorithms. Is something that the customer wants. All this is about, if the customer wants, the customer is going to pay. If the customer didn't want it, even though for me it's important to put good performance or good robustness or good whatever, it's not a requirement. The customer is the one that defines that. Now, key ideas. This is a human-centered process. Human-centered process. The requirements is what one human being is going to tell me. Moreover, I can influence that human being to make a requirement something that I consider important. But the final decision is that human being, that discussion, that conversation is the one that is going to tell us what we're going to implement later. That conversation is the one in which you are trying to convince your customer to spend more money to make the system better because you know what is better. Performance, robustness, nice user-friendly graphical user interface, whatever. It's not going to become a requirement unless that people tell you yes. It is a big problem. When you have humans working, the customer is a human, you are humans, cognitive problems. Cognitive problems is a fancy way to say we have difficulties communicating each other. I can be sure that I am explaining myself 100% well, that I am describing this big project that I have in my mind. But maybe you are getting an idea that is not exactly the same as mine. It's not about who is correct or not. The customer is always correct, period. Now, for the requirements, there are going to be several different ways to collect them. Obviously, the first one, the one that we have been talking so far, talk with the customer. Sometimes talking is not going to be enough. Sometimes we need to do other things. The key idea is what we can do to improve communication. Talking help is the first step, not the only one. Fancy ways to say a summary. A summary, you can do brainstorming with your customer. The customer do not have the answer. Give some answer to them, but the customer select the final one. You can make a survey. Have questions prepared, multiple choice, and make the life of the customer easy to select one choices, graphical user interface or web interface, phone application, mobile or web, both. Prototyping. If you remember, there is one software development process that is called that way, prototyping. The reason because prototyping exists, besides that you use this one to learn new libraries and new things, one of the most important things for prototyping is prototyping graphical user interfaces, prototyping systems. So you can arrive to collect requirements and show the customer An initial version. What you call an initial version could be, again, a prototype with only graphical user interfaces, or it could be some kind of software that you create quickly just to show, hey, it's going to work like this, like a Pac-Man video game with all the elements there, but maybe they are squares instead of circles and instead of pretty nice ghosts. Something that you do to ask, this is what you want. This looks like the things that I need to do. Well done, but the idea is there. One important thing, something that you have been using, something that I asked you to follow with the storyboarding, create scenarios. You do not do a prototype of the full system. Usually we do prototypes for one particular scenario. We split the system in scenarios. What is a scenario? A scenario, think about that these people on the stage, one scenario, one act, a group of people, a group of actors doing one particular performance, one part of the thing, one chapter in a book, if you want. Yeah, there is going to be the book with 10 chapters, 12 chapters. One scenario is going to describe to you what's happening in one of them. Which are the people, the actors involved, what they are going to do, how they are going to interact, when is going to be the final result. This word is important because it's the one that we're going to use for document requirements. We're going to create scenarios, more information coming. At the end, the last one, observation. Sometimes it's easy to ask the customer, show me how do you do the thing right now? Maybe using paper, maybe using Excel, maybe using whatever resources you commonly use, paper. You check what it's doing, and your work is to translate that real world scenario to the system to do exactly the same. Canvas. What do usually you do in the classroom? You print your homework and deliver your homework to the instructor. Okay, that is what happened in the real world. Canvas. Let's do the same. Instead of your paper, a web page. Instead of delivering to the instructor, submit. Okay, the instructor have all these pages. Let's create a graphical user interface for the instructor to access all the documents, digital documents. Survey, brainstorming, observation, talk with the customer, a human-centered process. At the end, this is your goal. At the end, it's not just like I am talking with you, customer, and you tell me this, and I am just going to put in paper or in a contract, whatever you told me. You need to think about this confession. A confession, yeah, it's not only about listening and documenting, but you need to analyze every single sentence. You need to validate that sentence. We need to talk about the modeling, that is going to be the documentation of this, and the interpretation. Guys, these are fancy names in the paper for what we review as this. Your conversation with the customer, all this information that we have been reviewing the previous weeks, all these sentences, they could be correct or not. Your work is to make them work. I ask you for practice. I give you the slides of the previous lecture. I put red color in several different of the requirements that we cover. Moreover, I give you more from your homework and more from other projects. I give you information. Please, the lecture time is very small. Ask for help in office hours. Send emails to the PAs or to me. Professor, I think that this is the correct solution in this one that you marked red. I am right or not? And believe me, I follow up with you by email. I am not sure if all of you have the same question. I spent one lecture reviewing some examples, but I am sure some of you are going to have more questions than others. Some of you are working in those examples and others are not, because it's not a great activity. Feel free to ask questions. My recommendation, because of the message in the chat, we're going to continue working on this, so don't worry, but a very good advice. Try to work with the things that I recommend in my message during the weekend, and any question, please ask. Uh, do not wait to one day before the meeting, right? Practice. Anyway, now, talking about this specification, what we are going to do to document the requirement. And in this point, these are our options. We want to document requirements, both obviously functional and non-functional. We want to use natural language. That is the option that we have been using so far. All the sentence in my slides, all the sentence that you submit in your homework is natural language. We're trying to document requirements with graphic, with natural language, period, English. Do that work? And hopefully right now you're thinking like, well, more or less, right? It's like we can document requirements with natural language. We can document requirements in English. We did it. The final result is not exactly the best. Can be done, yes. Is the best option? No. We need to move forward. Okay, better options. Better options, these three. Number one, mathematical specification. That is the best one. That is the best one. Why? Because math, by default, there is no ambiguity in anything that you create or specify following mathematical language. I am talking about an equation. Can we create something close? An equation, predicate logic for a system? The answer is yes, you can. However, it's not exactly the easy thing to do. Again, don't worry. This is very good. However, complicated. However, not work for any kind of system. So, okay, we don't like this one. We like something better. But most of the people do not want to move here because you do not necessarily have the skills, or you do not need want to spend the time to do something like this for everything that you create program. Moreover, not every single software is going to be able to be represented with mathematical models. Okay, forget about mathematical models. Okay, forget about natural language. At the end, we have two options. And those two are the ones that we're going to use here. Those two are the ones that you use outside there. Number one, the first one that I am going to review with you starting today is we can document requirements using a graphical notation. Graphics, yeah, graphics. Diagrams. A picture. We're going to use a picture to represent, to document our requirements. Why pictures? Because the humans, the brain, our brain like the picture. Some people is visual, and looking to a picture is better than reading a paragraph. There is an option, diagrams, graphics, to represent requirements. This is going to work. Now, second, the problem with the pictures is usually they take time. Yeah, if you're going to draw something, sometimes you need more time to draw that something than to just write 2 or 3 words. Text is something that sometimes you still need. And by the way, we use it. But the problem with natural language is if I told you that you can use whatever you want, write whatever you want, I am giving you too much freedom. What if we use structured natural language? Structured natural language. I am talking about templates. A template, yes, you're going to use English, you're going to write text, but instead of giving you the freedom to write the requirements in any way that you want, like so far, I am going to give you a template. this form with specific fields that you're going to complete, and that is going to be your requirement. A template or a diagram, our two options. That is what we're going to do. Good. Now, another problem. We're going to document requirements with a graphic, a diagram, or a template. But there is two ways to create software. At this level, you're familiar. You can create software in an agile way or in a plan-based way. Plan-based, I am talking by example waterfall, right? But it's not the only one. Agile, I am talking by example Scrum, but it's not the only one. So two things. Tell me, what is the difference, talking about requirements, obviously, here and here? What is different regarding the requirements in each of these approaches or between these approaches? Any idea? Someone is there.
We need to gather all of the intricacies of a requirement in a plan-based approach, whereas for agile model, we can show them a prototype of the initial understanding and get more clarification.
Good. So I am going to use that one. Hopefully everyone agree. Big difference, and I put one word there. The idea. Plan-based. You need to have all the requirements right. That is the core idea there. You're going to do a plan-based, and your plan depends on the requirements. You need to have all of them. Remember what you learn about this is flexibility here versus here. Now, this looks to be very nice. This looks to be like the one that we want to work with. This looks like, oh, very sad. We do not want to work in that because it's not flexible, because I need to have all the requirements. Tell me, every single piece of software that you do can be done with the agile methodology, and therefore we can review this path and ignore this one? Yes or no? Good. I like that answer. Remember, depends on the project. Guys, today we still have projects in which we already have all the requirements from the beginning. And moreover, we need to work in a plan-based way. Projects in which human lives are involved usually are going to be here. The flexibility here means problems. However, most of the web applications and mobile applications that you can develop in the Silicon Valley are going to be here. They are not human lives involved. I mean, nothing happening. The next version of your browser crash. Usually, that is a good point. Agile is good for small and medium-sized projects. Yeah. When you want long-term projects, we need to be careful what that long-term means. Long-term, like an operating system in which we can continue evolving forever. But again, there are not human lives involved. We can basically forget previous versions or previous modules because they are going to be replaced forever and forever. That could be agile. That is agile. However, there are other projects in which previous versions are still important today. You can think about the financial systems. All of that, we have still several source code in COBOL and things like that. We need documentation for that. And when the documentation is important, like in those scenarios or airplanes and other things, again, human lives involved, we're going to select the plan-based. Depends on the project. Now, because depends on the project, something that we need to do is to cover both. We want to create requirements. We need to review what happened with the requirements in a plan-based approach. What do we do? How we create this contract that we're going to use at the beginning of everything. But also important, how the requirements are handled in an agile way. And we need to talk about your product backlog and how you assign requirements to the people and so on. So for the product. We need to review requirements here, plan-based. We need to review requirements here, agile. One thing that is going to be common, one thing that is helpful in both approaches, and we're going to start there. The first thing that you need to do before creating a contract for the plan-based or before creating your product backlog for the agile, the first thing is you need to understand what you are going to do. Understanding what you're going to do. You know what? The best way to understand what we're going to do, even if we're working with someone else, even if we're doing brainstorming, if I put all of you in a classroom or a group of you in a classroom to define a new software, what is the requirement for a new software? One thing that you're going to do is to use the whiteboard, and someone is going to start writing things or drawing things. And in particular, those drawings are going to include circles, lines, colors, because it's just the way in which our brain works. It's just the way in which we communicate. Hey, we have this idea. Okay, we have this idea. Oh, this idea here and this idea here are important. Circles. Oh, these two maybe are connected. A line. This graphical representation is going to become a diagram. And those diagrams are going to be helpful to understand what we want to do. Moreover, for the plan-based approach, those diagrams are going to be part of the contract that we're going to create. I am going to work in Agile. Don't worry. The diagram is not something that you're going to put in your product backlog. Forget about it. But if of each of these circles here, each of those things are going to become an item in your product backlog. You don't care about the diagram, but think about you put the circles, and those circles are going to be important. What I am trying to tell you is this diagram can help us to start. In one part, it's going to be part of a document. We're going to review that. In the other part, the diagram is going to disappear. Still, it's going to be important to work there because it's going to help us to continue with the backlogs. Good? So the diagram, our friend, the diagram. And the diagram works for both, right? But now that I'm going to start with the diagram, and the diagram originally starts here, let's think that the following day we're going to be talking there. Then we go back and go for the item. Good. So the diagram. I am sure that you're familiar with diagrams. If you're software engineers, if you take one introduction to software engineering course in some moment in your life, you're familiar with several different diagrams. In particular, you are familiar with something called UML. Yes or no? If I ask you what is UML, you know that? I have at least one yes. Hopefully that is yes for the 100 people connected. Everyone, yes. Another one of these? Okay, good. So guys, UML. In UML, you have two big categories of diagrams. Hopefully you remember. You have diagrams to represent the structure of your project, and you have diagrams to represent the behavior of your project. Two big categories. I am not talking about behavior diagram and structure diagram. No, I am talking about categories. The diagrams are going to be here. Two groups. Structure. Remember, which is the most famous, the most common diagram in UML to represent the structure of the software? What is a good example of a diagram in UML that is part of this group? Yes. UML, class diagram, to represent the structure. The structure, yeah, your classes and your connection between classes. We are reviewing that in 564, right? Is the class diagram, the structure. How the software is going to be transformed to lines of code. Good. Behavior. Behavior is what we're reviewing here. Behavior, remember, requirements. Behavior, service, functionalities, reaction. These diagrams in UML are the ones that we're going to use to represent our requirements. The behavior category. Now, we need one of these. In fact, we're going to be using three here. The first thing that I want you to notice, one category for the requirements, 563. One category for the structure, class diagram, 564. We don't care about this in this class. In the same way that in the other class, 564, you don't care about the behavioral ones. Now, the behavioral ones, the diagram, the name of the diagram that we're going to use to represent requirements is this one, use case diagrams. Now, use case diagrams. Also, we're going to have activity diagrams and state diagrams. There are more, but those three can solve our problem about defining what the system is going to do, the behavior of the system. Use case diagrams, activity diagrams, state diagrams. My goal for you to be experts in these three in the following weeks, we can help. Good? Now, let's start with the use case diagram. These are all the diagrams in UML. For you to know all of them, basically we cover that guy, and we're going to cover this guy, and we're going to cover this guy. And as you notice, they are siblings, same line, and all of them behave. That is what we're going to do with UML. In these diagrams, use case diagrams, what do we have? We have three elements. There is only three elements. The good news, you're going to find those three elements familiar. Why? Because we have been already using some of those elements. What do we have? Number one, we're going to have actors. Remember? The actor could be the user, a particular kind of user, or could be one system, a particular kind of system. Actors are going to be there, are going to be in your diagram. Actors in your diagram, they are going to be represented like this. Remember the guy that I have been using in the whiteboard? That is your actor, and the one that we use for partner, for player, for the ghost, and so on. Step number one, storyboarding. Identify your actors. You identify your actors, you put your actor in a picture. That picture is going to become a diagram. That diagram is a UML use case diagram. Second, use cases. We're going to call use cases. That is the name here. To our functional requirements. Each functional requirement is going to be represented by one use case. The functional requirements of the system, each of them is going to be one use case, and use cases are represented with an oval. Each time that you saw an oval, that oval have inside a use case. That oval is a requirement, a functional requirement. Guys, common error. You do not put here in this diagram the non-functional requirement. Non-functional requirements for now are outside of our work. We are not going to work with non-functional requirements in the following days. We care about the functionals. Those are the most important ones. This oval represents functional requirements only. Common error in your quizzes, in your exam, to put an oval for something like usability or performance or things like that. They are not going to be in this diagram. Why not? Because they are not connected with one particular actor. It's not something that one actor is going to ask for. The player in the Pac-Man is not going to ask for usability. The player in the Pac-Man is not going to ask for performance and so on. Those are things that should be in the full system. So, functional requirements, actor. And the last one, those are going to be the only two elements, and they are going to be related. They need to be connected. We are going to connect two things. Number one, actors and requirements, makes sense that they are going to be connected. Remember what we did in the whiteboard. We start doing this kind of connection. However, two requirements, there are going to be some times in which we need to connect two requirements. There are some times, and some of you asked me about this in the classroom, looks like this guy here and this guy here, they are somehow related, right? Do you remember the Pac-Man moving, but also the collision detection? It's like, well, if I want to check collision, it's because the Pac-Man is moving, or it's because the ghost is moving. So these guys somehow work together, somehow are connected. Can I show that some way? Yes, we're going to show that in some way. If I have this oval here, oval one, and this oval here, oval two, and I draw some kind of connection between them, it's because they two know each other. They two kind of work together. Relationships. Now, what kind of relationships I can use before that? What if I have two actors? Can two actors be related? The answer is going to be yes. Sometimes one actor is connected with another one. One actor is family from the other one, or is going to do things together with the other one. Connection, connection, connection. Now, I am drawing these lines to show this idea of connection. However, what can I do to connect those elements? I only have four options. The two most important, the ones that we need to review, the new ones are the last ones, extension and inclusion. Those are new. Inclusion is new, and extension, I need to tell you, is not extend like inheritance. It's a different thing. We need to talk about it. Inclusion and extension, both with the dashed line, both with an arrowhead. I'm going to talk about them in detail. Those two in particular, those two are new. Those two could be confused if you have previous background with class diagrams. If we're working in class diagrams in the 564. The other two, we have inheritance, and I am sure that the notation is familiar to you. The solid line, only solid line, there is no implementation here. And the arrowhead, that is the triangle in white. Extend, include, inheritance, and the last one, use a line. Use a line, the equivalent to association. Use a line is going to have one use only, and I am going to talk about that in the example. Association, the line. Inheritance, you know what is inheritance. Apply the same way to requirements. Inclusion and extension. Four things, four lines, 1, 2, 3, 4, that I can use to connect the circle with another circle, or the actor with another actor, or maybe an actor with a novel. Two elements, four ways to connect them. And that is going to become my representation of my requirements with a use case diagram. Now, when and how use these connections? Our goal is to create something like this. Something like this. Let's see. One, association. The line, the trivial line. All the lines that you saw here, like this one. You use that one to connect an actor with a use case. You use that one to connect an actor with a requirement. Notice here. The line with an arrowhead solid is basically to connect my actor, whatever is your actor, with some functionality that that actor is going to trigger. The medical receptionist is going to trigger the register of a patient. The medical receptionist is going to trigger view personal information, and so on. Actor and requirement are connected with a line, a simple, trivial line. They are associated. Yeah, I am going to provide those examples, don't worry. Guys, actor, requirement. It doesn't matter what is the requirement. This is the connection. What I am telling you, this is okay. Actor, requirement. Do you think that we can apply, for instance, something like this, inheritance, or maybe something like this, inheritance? What do you think about using a line with the arrowhead, the triangle that represents inheritance? Do you think that makes sense to do inheritance? The actor is the child and the requirement is the parent, or the opposite? No. Makes sense? Yes, no, in the chat, or you can speak. Think about the player is the parent and moving is the child. The action is the child. No, good. Hopefully I don't have any of these in your quiz or in your exam. Guys, never, 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 as a rule, you use the connection of inheritance between actors and requirements. Forget about that. Well, what about the actor? And remember that we mentioned before this dash line include. I haven't explained yet what is include, but just to show you the idea. Or what about this line? And again, I haven't explained to you what is include, what is extend. I am going to do it. But my point right now is you cannot use them between an actor and a requirement. Okay, Professor, what you are telling us is that the only thing that we can do between an actor and a requirement is the line. No inheritance, no inclusion, no extension. Yes, that is what I want you to know. The only relationship between actor and requirement is line, association. The requirement and the actor, they are associated. Okay, now that we're talking about this inheritance, an actor, inheritance, another actor, a requirement, inheritance, another requirement. Uh, can we have inheritance between actors? Like this. Yeah. Can the parent be an actor and the child be another actor? That is something that is possible. For instance, think about Canvas. In Canvas, professor and a student. There are several things that I can do in Canvas that you cannot do, right? So there are things that you do that I cannot do. Well, I can change my profile to student, but usually you have things that are for students, and I have things that are for the instructor. We are two different actors, professor, student. Tell me, there are things that we both are able to do. Things that doesn't matter if you are the professor or you are the student, but we both need to do. For instance, authentication. It doesn't matter if I am the professor, I am a student. Authentication is applied for both, right? What do you think about creating a parent, user, and that parent, the user, have a child, and the child can be student. And basically the idea is if I connect this guy with this all, level one, what I am telling is because this one have access to this service, this one have access to authentication here. If I give you the example, this user is able to be authenticated. What about the student? Student also is going to be able to be authenticated because it's going to inherit the capability of calling this requirement. And professor start. Did you notice the idea? It's the same that for the class diagrams. Instead of connecting this here and this here and the other one there, instead of making several lines to the same requirement because all of those need to access that or trigger that, one parent, all of them are part of the family. The only thing that I need is to connect the parent. So inheritance with actor work is something that you can do to create families that access a particular group of services. Good. Now, inheritance with requirements is something that we're going to review, but it is possible to have two oval and one oval is going to be parent and the other is going to be child, and the oval can have as many childs as you want, no problem. Inheritance only between ovals or only between actors, but as we mentioned before, you cannot combine them. Actor cannot be the parent of an oval cannot be the parent of an actor. That is the limitation. Include and extend. These two guys only between ovals. This is wrong. This is wrong. The only thing that you can do is oval, oval, include, or oval, oval, extend. This is good. This is good. Can I use that between actors, an actor and another actor, and then I am going to connect this with the include? No. With the extend? No. These two guys only work with ovals. So the summary, if you have actor and oval, always association. Inheritance between ovals, all of these are ovals, or between actors, all of these are actors. And inclusion and extension, only for ovals, only for requirements, not for actors, never. 1, 2, 3, different levels. Good? Now, inclusion and extension, and the difficult ones. Guys, inclusion. Inclusion is the following. Think about you have a car. If you represent building a car as one requirement, it's something that you want to do, right? The system is going to create a car. So that is my requirement. That is something that I need to do. Hey, that one is a requirement? Yeah, it's a requirement. Create what? Car, one requirement. No one is going to complain about the size. No one is going to complain about whether or not it's independent, clear, etc. It's invest. Create a car, draw a car, depending on its build color. That is one requirement. Now, sometimes we're going to have this problem. It's like, well, that is one requirement. It's one thing to do. But creating the car is complicated. Even though it's one thing to do, what if I split in V8 engine? And what if I split in, well, V8 other things like the wheels, among others? What I want to do is to create a car. That is, if you want, is what I want to do. That is what my actor, my user, the one that represents me wants. So my user is going to be connected with create a car, my goal. However, I know that creating the car implies to do things that maybe other people that tell me to do, or things that even though I am going to do, I would like to keep it separated. The coupling. You are going to do one thing, but sometimes you need delegates. We're going to talk about that in classes. Sometimes you need just to separate the class in more than one because the class is too big. With the requirement is the same idea. Is one, but it could be useful to split. It could be useful to split because maybe this one is something that someone else already did. Maybe that one is something that I can get from a library. Maybe that one is something that another developer can do for me. However, I can split that, separate that, but this guy is going to be connected with this guy. This guy is going to be connected with this guy. Notice, create engine or create the wheels. Those are not connected with the user. The user do not want an engine. The user do not want wheel. The user want a car. But in order to do the car, someone else is going to help me with the engine. And in order to do the car, someone else is going to help me with the wheels. That is my representation. Think about this. As a user, I am calling a method car, a method. And inside of that method, you are working. You have your if, else, loops, and so on. But in some point, you are calling a method engine or creating an object engine. You are creating an object or calling a method wheel. So you are not doing the work. You do not have there the source code for engine or wheel, but you're calling someone else that is going to give you that. With requirements, that is the concept of inclusion. Inclusion, very important thing. The arrowhead. Car is the important thing, the big one, right? The arrowhead is going to point from the important one, the big one, to the small things that you have. Car is going to point to engine. Car is going to point to wheels. So that one, the wheels are inside of me. That one, the engine is inside of me, and so on. Think about this include like inside of. I have it. They are part of me. I exist because I have those things there. And the relationship is going to be a dash line. I am adding these lines here. I should be deleting things. And you're going to put the stereotype include. You're going to put the stereotype include. This one, the big one, the car, is called the base. These ones, the small ones, are called the additions. And hopefully you get the idea. The big one, the base, is taking the others and adding them inside. Guys, if I need to use the example of the class diagrams, the closest thing here is the relationship between two classes in which you are using the diamond. Moreover, this could be the equivalent in a class diagram in which you are using a black diamond. Don't worry, this is just a comment for the people taking 564, 564. The example with the diamond, the connection between two classes with the black diamond is exactly the same thing that I am describing right now here between requirements, the inclusion. If you're not familiar with class diagrams, forget about this comment. This is used to include the line connecting two things. One is the owner, the other is the thing that I have inside. Make sense? Question. Think about this. I have an actor, a user, and the description that you give me is, well, let's think that this one want to do something like copy and want to do something like paste. Two things. A common idea is, well, copy and paste. Just because in order to do the paste, I need to do the copy. That is the idea with the names. Then that means that paste is going to include copy. Or another example, user Uh, Canvas, you're going to do a quiz, right? Uh, Something that you can do as a student on Canvas is present a quiz. But another thing that you do with Canvas is authentication. Oh, wait, but before doing a quiz, something that I do on Canvas is that I authenticate. That is something that happened before. So if that is the case, then I want to do and include the quiz and authentication. Hopefully these two examples are kind of the ones that I received before. Guys, no and no, no, no. Why? Let me explain. What we try to represent with the include is that one thing is inside of the other. One thing happens always together with the other, that they are never separated. Include uh, copy paste. Could it happen that I do the copy but never the paste? Uh, can I press the keys that correspond to copy and I just forget and therefore I never paste the information? Could I try to do the paste even though I never copy anything and therefore nothing is going to happen? I think the answer for both are yes. Why? Because there are two different services, two different functionalities, two different things that the system is going to do. Uh, it is not true that one is inside of the other. It is not true that they happen together. Moreover, both are called by the user. The user is the one that called this, and the user is the one that called this. We are going to make a note in our requirements. It is a good idea that before doing a page, the user do a copy, but it is a good idea. Think about this like when you create an algorithm for sorting or searching, and it's a good idea that the array that you're going to use to do the sorting or the searching, it's a good idea that that array have some elements. But what happens if the array is empty? You cannot run the method to do the sorting. You can run it, and the method is going to be happy because it's going to return false, and that's it. One thing is the validation that we need to do in terms of the software, and a different thing, whether or not the requirements happen together. Copy and paste do not happen together. Copy and paste are not going to be connected with include because the copy is not inside of the paste or the paste is not inside of the copy. The other example, quiz and authentication. You can tell me every single time that you do something on Canvas, a quiz, an exam, submit a homework, whatever, something that is a good idea, something that the system is going to ask you to do is to authenticate. Now, here, two different ideas. Idea number one. Idea number one is that one. That one. In that idea, what the user wants to do is the quiz. Every single time that the user is trying to do a quiz, according with this diagram, the quiz includes authentication. Uh, Going back to my example with the car includes the engine. The car do not exist without the engine. Here, what I am representing there is the quiz do not exist. The quiz cannot happen unless I authenticate. Tell me, that is true in Canvas? And it's a tricky question because the question is, every single time that you take a quiz, you authenticate? Yes or no? Every single time that you select answer a quiz, you authenticate? Good. And hopefully you get the idea like, no. Some of you can be thinking like, well, yeah. Remember, you authenticate to go inside of the system. But once you are inside of the system, you can take 1, 2, 3, 4 quizzes. Maybe that is not the common thing to happen, but could happen, right? I am inside and I can take 5 quizzes and you do not authenticate 5 times. This diagram here, this representation here, is telling me that if I take 5 quizzes, I authenticate 5 times because authentication is embedded inside of the quiz. Again, think about this includes like one method calling another one. So what I am representing here is the method quiz, whatever that is calling another method authenticate. And the method authenticate is the one that do the service of authentication, right? That is not the case on Canvas. It could be the case in other applications. For instance, this diagram could be the diagram for something like a transaction in a bank. If you want to move money from one account to another, if you want to send money to your friend, usually this is going to be the representation. In that case, probably this is true because every time that you send money, even though you already authenticated before, you're going to be asked to authenticate again to prove that the person that is inside right now sending that money or moving that money is you. For a bank account, this diagram could be representing the situation. Authentication always happens together with the service. For Canvas, the reality is more like this. In Canvas, the user can do a quiz, yes. In Canvas, the user can authenticate. Two different things that the user can do. Now, you can be thinking like, professor, but if I try to do the quiz directly, like I copy the URL of my quiz and I copy paste that URL in another browser, I am not going to be able to do a quiz because the quiz is going to check if I am inside of the system or not. Remember, if I have a session. Think about this as developers. Include is not the same that a precondition or a validation. Include is something that is always inside at the same time together. Again, like one method calling another method. That is include. This idea of I need to review that you are inside of the system because you were authenticated before. That is a validation. That is an if else. That is checking a flag in the session. They are not the same. For Canvas, the diagram, the requirements, two different requirements, and they are not connected. Taking a quiz or exam or other things, and authentication, they are separated. And a use case diagram is not going to show you the order in which the requirements happen. That is not the goal of the diagram. The diagram is used to show you what the system can do, not the order. I have quiz here above, and I have here authentication below. And I am telling you that the user do both. I am not telling here in any place that authentication should happen before. That is going to be in a different place. I am telling you one of my developers is going to implement authentication. One developer should implement the quizzes. And yes, we need to talk about validation, precondition, a condition that maybe is going to be there in the quiz if the session have this flag. That's it. But it's not about this one, calling this one every single time. Makes sense, guys? Tell me, any example of inclusion in the requirements that you create for the system on the video, for the project that I asked my students to do? Think about all the requirements that we have. We have 7 or 8 that you did it. Each of those 7 or 8 are going to be oval, as we described before, and we have only one user, right? The user of the system. Any of the requirements there, those 7 or 8, are connected with an inclusion relationship. There is something that includes another one. You did your homework, right? You remember what you did, or you review my slides. Two requirements in your homework that are connected with an include, or that should be connected with an include ideas. I like that one. Let's see. Do you remember that you have this plot requirement? Do you remember that you have a requirement that is about plotting something, right? You have that one. Merge. Do you remember that you have a requirement about merging data? Moreover, do you remember that you have this requirement about upload files? In particular, you have this requirement about upload the roster. And if I remember correctly, you have this also requirement for upload the appendix. Remember, you have these, maybe others. Inclusion and validations. I think that you could agree with me that I have a user, and one requirement is to block the roster. It's something that the user wants to do. I am going to do this connection. Guys, never, never, never a node in a diagram can be alone disconnected. It should be connected with something. Something that the user can do is to upload attendance. And I was missing the save, right? Something that the user wants to do is to save things. Something that the user wants to do is to merge things. Remember, the attendance together with the roster. Something that the user wants to do is to plot all these things. Now, tell me, if I remember correctly, the user wants to upload the roster. The user wants to save. The user wants to load. The user wants to load the attendance, but there is any option in the menu or something for the user to ask to do the merge of the information? Do you remember if this user is triggering or asking for the merge? When the merge happens, how the merge occurs in the description that the customer gives you. Is a menu option? Like I give you this file and I give you this file, and then I go to the menu and I select trigger this action. And at this point, you remember like, okay, no. It could be possible, right? You can put an option in the menu for merge, but that is not the case of what I asked you to do as a customer. What happened is when you upload attendance, the merge starts, right? Always, 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 always that I upload attendance, always, always, always the merge happen. Can we say that the merge is inside of uploading attendance? Can we say that when you upload attendance, then the merge is going to happen? Can we establish a connection between them? Now, a connection between them, yes, but I put the connection. That connection is use association. One is going to call. You can think about this user is calling this one, and this one is going to call this one. One process, the next process. Is inclusion. Load, include, match, occur always. We need to continue talking about this, but so far, I think every single time that I upload a file, that uploading the file is going to include that file is going to be merged with the other, because I really do not need attendance if it's not for merging with the roster. Moreover, do you remember that merge have a special case in which you validate that what happened with someone that is in the attendance but was not in the roster? Remember that there is something there, like you validate if someone is not there and something happened when that is the situation. And some of you give me not just one requirement for the merge, but give me one requirement for the merge. And some of you notice that this validation was big enough to be another requirement. Tell me when validation happened. And hopefully you agree with me, the user never called for validation. But moreover, the upload never called for validation. The validation is something that always happens when you are doing the merge. So if you notice the diagram, as a user, what I want to do is to upload attendance. What I want to do is to put the attendance there in my system. Internally, every single time that I do this is going to happen. And every time that I do this is going to happen. I have three things that are going to happen, 1, 2, 3, in a line. My diagram is telling me my user really trigger 1, 2, 3, 4 different things. However, I have 6 requirements so far. Clear. Good. Okay, guys. I am going to stop here. Please review my previous lecture, the slides. Be sure that you agree or can identify why I put in red some of the text there. If you have questions, let me know. Next lecture, I am going to talk about extend, and obviously we're going to do a lot of examples with diagrams just like this. Good. See you Wednesday. Thank you.